In this video, we're going to just quickly look at ethane cracking and cycloalkenes and cycloalkynes. So ethane cracking is a way to convert ethane into ethene. And in doing so, it gives off a hydrogen molecule. So this is called a cracking reaction, and cracking reactions make something that's bigger into something that's smaller. The ethane cracking also produces this useful hydrogen byproduct that is nice to use in reactions. And this works pretty well for making ethane, which is a major chemical, or ethene. Ethene is super important for making polymers and synthetic molecules. So it's a really good starting point for doing a lot of reactions with organic chemicals. So we need quite a bit of it. The cracking reaction will work to make other things. So you could make propane into propene. So if we had propane and we put it under the same conditions, we could make propene and hydrogen. But it doesn't work well to do any molecules that are bigger than that because we start producing isomers. So if we had butane and we cracked it, it's possible to crack it, but the problem is that it'll start to make but-1-ene, and it will make but-2-ene. And as soon as you start getting more products that are coming out together, then we need a way to be able to separate them, and that's a pretty tricky process. And so they tend to only do this kind of reaction with extremely small molecules, because as soon as they start getting bigger, the byproducts, secondary products, start to become a real problem. Cycloalkenes and cycloalkynes are very reactive. They're not super stable. They definitely exist, and some of them are more stable than others. But basically the ring structure is a little bit more rigid, and the double bond is a little bit more reactive. So they tend to be quite reactive unless they've got really well stabilized, and we don't go into any of that. But when we're naming a ring structure, we will always count the double bond as occurring on the first and second carbon. And so with cyclohexene, you can see that my first carbon is going to be on the double bond as well as the second carbon. You could count the other way, it wouldn't matter, right? So if you counted this as 1 and 2, it doesn't matter, it doesn't make a difference. But in the next molecule, there is an ethyl branch, right? It's got a 2-carbon long branch coming off of the cyclohexene. And this does matter. So if it goes 1, 2, 3, I get the double bond is occurring on the first and second carbon, and then I have to continue counting around to number my carbons, and so I get a 3-ethyl cyclohexene because the hexene is going to be on the first and second carbon. On this one, this is going to be my first and second carbon, but we still need to have a way of deciding which one goes first. And so if I went 1, 2, or 2 and 1, which way do I number it? So in this case, either one's going to give you the same, cyclohexene, but because we have no other way of deciding, and this is an ethyl and this is a methyl, E comes before M in the alphabet, so they list the lower number goes to the lower or to the earlier thing in the alphabet. So we're going to go 1-ethyl, 2-methyl, because you don't want this molecule to have 2 different names, so you wouldn't want it to be 1-ethyl, 2-methyl cyclohexene, or possibly 2-ethyl, 1-methyl cyclohexene. We want all of the molecules to only have one name. So if there's no other way of deciding, then we go to alphabetical order, gets the lower number. It doesn't happen too often. One other thing I want to mention in the saturated aliphatics is the bromine test and potassium permanganate test. So both of these are colored things. So bromine, Br2, is an orangey brown color, and potassium permanganate is purple. And when you put an alkene or an alkyne with bromine or potassium permanganate, the color of the bromine or the potassium permanganate will disappear. And the reason is that it is reacting at the double or triple bond. And so as it's being reacted, it's using up that colored chemical and the color goes away. This is a way to test for an aliphatics that are saturated or unsaturated. If it is saturated, it doesn't react and the color doesn't go away. If it is unsaturated, so an alkene or an alkyne, the color goes away. And that's an important test that shows up on unit exams and final exams. And so you really need to be aware of that test. And a positive test for an alkene or an alkyne is that bromine or potassium permanganate color disappears.